To talk about the number of primes, we need to understand a function called the logarithm. And the logarithm is something that we have not talked about. But the logarithm says if e to some number is another number, like if e squared, whatever e squared is about 8, then that means log of 8 is 2. E to the 2 is 8, log of 8 is 2. That's a weird definition.
Yeah.
But Jordan Ellenberg in his book How Not to Be Wrong has a great way to get around this problem of the complicated logarithm. So he defined something called flog, which I think stood for fake logarithm.
Or maybe logarithm.
Or flogarithm. Maybe it was friendly logarithm. I don't know. But it's just the number of digits in the number. Is a good way to think about the fake logarithm. So let's think about that for a second. So the actual logarithm of 100, we would need to go to my calculator, 100, and then there's this ln button, is 4.6. But what's the fake logarithm of 100? It's the number of digits.
3.
Well, there's 1 digit. There's the 4.
Oh no, of 100 though. The fake logarithm of 100.
Then it would be 3.
It would be 3. Okay? Now let's try 1,000. The log of 1,000, which is this ln button, 6.9. What's the fake logarithm?
It'll be 4.
4. And 10,000 is 9 versus
5.
5. So it's an okay approximation.
Yeah.
So the number of digits. So the number of primes less than n, some number n, is approximately equal to n over log n,
And we could use the
which is
logarithm.
approximately n over fake log. The number of digits. You take the number divided by the number of digits. So the number of primes less than 100 is approximately 100 divided by 3, which is what?
Around 33.
33. And there's actually 25.
That's pretty close.
Pretty
Pretty
close
close.
approximation.
Pretty close. So people understood this for a long time.
Yeah.
Long time ago. People understood that. And that's a pretty amazing fact, actually.
Yeah.
But the distribution of primes is a little harder. It doesn't mean there's exactly this, it just means it's approximately that.
Yeah.
And one question people wondered about, sorry about banging the camera. One question people wondered about for a long time is when you see prime numbers, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, etc. A lot of times they come in these pairs of 2. They're just separated only by 2.
Yep.
29, 31. These are called twin primes.
And there's one triplet of primes, 3, 5, 7.
Yeah, that's actually the only one. But nobody knows, even today, this is an unsolved problem, are there infinitely many
Double prime.
twin primes? Just a couple years ago, a professor from the University of New Hampshire, a guy named, last name is Zhang, Z-H-A-N-G, hopefully I spelled that right. He proved that there are an infinite number of primes that are separated by at most, 70 million.
So it went from infinity to 70 million.
Well, right, it went from not necessarily infinity, it went from them not knowing.
So unknown to 70 million.
Unknown. So the question was, do the primes eventually just kind of keep spreading out forever? Or do they clump together at least a little bit? And he proved for the first time that they actually don't spread out forever. There's infinitely many primes separated by at most 70 million, so they don't always spread out.
And didn't they last year they proved it 700, the gap was closer to 720?
I think it might even be lower than that, like in the 200s. People believe that there are infinitely many twin primes, but nobody knows how to prove it. And it's one of the most active areas of research in math, or at least it was a couple of years ago. And it was actually pretty fun to watch, because a lot of times in math, what people are doing in research is very difficult to understand.
This is pretty easy to understand.
It's pretty easy to understand what they're doing. The techniques and everything are maybe not as easy, but it was all happening right in front of your eyes. It's pretty neat, pretty fun to see. I think 100 years from now, people will look back at his proof that the prime gaps are finite, and that'll be one of the biggest. That'll be remembered as one of the biggest discoveries of this century.
Wow.
Yeah, and it happened when you guys were alive. Pretty cool. Pretty cool. All right, good. It was fun talking about it this morning, guys. Any questions?
No, I think I understood it.
Okay, good.